Hello, good morning. Um, Welcome to my talk. I'm super excited to kind of see you all here. And I hope you're enjoying the Berlin weather. Those who are new to Berlin, most of you guys might have got a sneak peek of how Berlin weather is. So imagine working in a team where you have the freedom to develop features end-to-end, not only looking at the UI part of it. Of course, we as Android developers are passionate about the UI layer, bringing the best UI experiences to the user. But just imagine where you can actually define the feature from its inception on how the user interacts with how you actually store the data in an optimized manner and, the end-to-end feature of it. So that is something like, I have experienced it from last eight months, I must say, so this is all about, my experience of why it is easy for Android developers to develop microservices, to build microservices. So this is Manny. I'm a senior software engineer working for SumUp, a payments bank. Now we would say, it provides financial solutions for small and medium-sized merchants. I'm working as a Kotlin developer, but now I'm actually both, like an Android and Kotlin engineer. So the story goes back to probably 6 years when I started Android development. Android is something like I'm super passionate about because this is something whenever you develop a feature, you can actually see what is happening. Immediately, you can get to see the feedback right before your eyes, rather than doing something in backend where you don't even know what is going on. Like you probably might create a service and you can't even see what it is. So, but as I said, the Android is something like it's super cool. So I started working on it. It's been 6 years where I have kind of experienced the ups and flows, the ebbs and flows of how the Android development is, and using the different libraries. And now we have Jetpack Compose, and I'm pretty sure we are going to evolve in such a way that things would get much better. But 7 months back, the time came when I kind of moved to SumUp, and I'm the first developer who joined as an Android engineer. So one fine day, my manager came to me and then said, "Hey, Manny, you know what? We have a really good opportunity for you, and I think you might like it." So they said, why can't you do Android backend development? Because we have a backend engineer who is going to join in 2 more months, and you're the first engineer to join our team. So it will be pretty exciting for you to do backend. And I'm like, no, I'm not going to do it. and then she again said, "Manny, I think I can even help you. I know some things in backend, so I can help you." And I was like, that's even worse. Why do I want to? I mean, just imagine, the managers keep saying, I can help you everywhere in the coding, but I don't really want my manager to come and sit coding at me. So, but yeah, and then, of course, they have my own reasons, as I keep mentioning, backend is something, it's a different area altogether. You probably need to learn a lot more than what you've been doing in Android. It's a different tech stack. The learning curve is more. And it's an ocean. It is just not one part of it. So you actually need to learn a lot more. So that's one thing I always used to think. And then it's a shift in the career because Android is something I'm passionate about. But now the moment you move into, you change your course into backend, it's a complete shift. And most importantly, I have that FOMO, as you call, fear of missing out. There are a lot of things that are happening in Android. You can see yesterday in the talks and even today. So I have a lot of reasons. And one more reason is I can't complain about backend anymore. I just can't say, hey, the backend is not working. I can't go back to my kitchen and have a nice cup of coffee. So, but yeah, things folded out. My manager somehow convinced me. I realized after 5 minutes that I'm going to do backend. And yeah, I think she's a really good manager. But yeah, so then I started my journey on how it is. But all of the reasons which I kind of came across, are these really true? Are you going to learn some? Of course, you're going to learn something new, but is it a shift in your specialization? Is it completely different? So all of these questions, in my opinion, I would say yes, they are true. But for us, specifically as Android engineers, I think it's not. Because you're going to know in the upcoming 10 minutes. So I keep talking about microservices, but what is a microservice? So microservice is something you can assume it's an architectural style where a system, for example, let's imagine any of the e-commerce system. An e-commerce system or any of the system will be divided into minor, small parts called as microservices rather than a big, huge service, because that would actually help your system for the teams to kind of work independently. So each microservice can have its own backend, can have its own server, can have its own database, and it can communicate with different modules, just like probably by a REST API call, or it could be a gRPC. So that's what a microservice is. So if you think about e-commerce, like you have account management. Account management can be one microservice. A communications module, like notifications, can be another microservice. Product catalog is another microservice. Orders is another service. Payments is another microservice. So you actually divide your entire system into individual modules, which would even give you a flexibility to select your own tech stack. So you don't really need to go back to your team and say that, hey guys, the current backend is in Go, and all of the microservices have to be written in Go. No, you don't need to. You can create your own microservice, which is written in Kotlin. You can deploy it using your own database, and then, yeah, you're good as long as it's working, so you should be fine. So that's what microservice is all about. So I got an understanding of what a microservice is. Of course, I have to read a lot before even doing something. And so now I have to decide on what the technical stack is. So what should I even pick? So I looked around what is the technical stack and stuff like that, but then I actually ended up with this tech stack. As you can see, I don't think like you guys already know most of this. Gradle is something we use in Android for build. Kotlin, of course, the beauty of Android, which has happened in recent times. And we use JUnit for testing. And SQLite, more or less, the queries are going to be the same as long as it's RDBMS. And yeah, I mean, the Micronaut is something you might think like it's pretty, it's kind of odd one out here. I'm going to give a very quick brief of what Micronaut is. So Micronaut is actually a framework that helps developers to build APIs, And most importantly, it can be Micronaut, but you can even use different things. You can even use Spring Boot. You can even use KTOR, which is Kotlin-based. So Micronaut is a framework which actually helped me to build. It actually involves most of the features, like dependency injection. Most importantly, it's kind of cloud native. So I felt like it is pretty easy for someone who is an Android engineer to quickly jump on and start doing developing services. So that's what Micronaut does, and it's super easy. It has support for Java, Kotlin, and yeah, it's cloud native. So cloud native basically means it helps. It is already embedded with a server by its own, so you don't need to worry about how it works, the API gateways, and most importantly, the distributed environment. Like in this world of millions of requests coming into picture, you need a distributed network. Like as you say, like you need to have different services communicating with each other. So this actually supports that. So you don't need to include different libraries to even handle the latest technology issues which we have been facing. So I kind of fixed my mindset. I ended up that, OK, I have something like Micronaut. And of course, I don't know how complex it is going to be. It's going to be an adventure for sure for me. Now I have the technical stack that I have to build. And then the first thing that comes into picture for every code base which you build is the architecture. So what is your architecture going to be? I keep looking at different architectures, because my view is that backend is something, it's completely different. Maybe it's a rocket science. I need to know something else to even do backend. Because once the backend engineer joins, I don't want him to complain that this code is shit. I can't work on it anymore. I want to rewrite. So I don't want that to happen. So I was just looking at different architectures. But then I stumbled upon one which is called as clean architecture. And I'm pretty sure, like most of us know what clean architecture is, because we have been using in Android from longer. So I exactly used this one, clean architecture. As we all know, like clean architecture, you have presentation layer. It communicates with your domain layer, and the domain layer talks to the data layer. And as we call it, as like an onion kind of onion structure. So and to my fascination, that's exactly what people use in backend as well. You have in Android, if we call it as, we have viewModel, which is an entry point. View model is where whenever user performs any of the actions, the request comes to the view model. From view model, we actually go to use case. Use cases is the one which kind of handles all of different use cases. And then it communicates with the data layer, which is a repository. And the repository can fetch the data from local, which is Sqlite in Android world, or remote using retrofit or whatever your API clients. And in backend, it's the same. The only thing that changes is the controller. So controller is an interface which actually handles your get call, post call. I mean, if you're using REST, yes, get, post, delete, patch, put. So that's an entry point. And then the request flows into the use case. And from the use case, it goes to the repository layer. And then at the end, what you do is an API call. As I said, microservices, everything is different. So you can fetch the data from your own. For example, if you're building an account management, like probably your database might hold the credentials. And so you will actually fetch from the local, but you probably need to get profile information. So you will do an API call, even in the microservice layer as well. So a microservice communicates with another microservice to get the data. So which is exactly what we have been doing in Android as well. So if you look at the code, it's pretty similar. There is no change as well. You can see that, the only thing that I can see the change is the annotation. You call it view model. And here you call it as a controller. And the rest of the things, you have a use case. This is just a to-do app which I kind of created. So you can see like you have a use case. And then that's all. The use case will have execute. I do the same thing here as well, execute. And yeah, you call it inject here, and you mark it as singleton. So I mean, if you look at the code, it's pretty much similar. The only thing that changes is the controller and view model. And that's all we actually need to know about this. And then the next part comes is, OK, like I know like my tech stack. I know the architecture. I know how to actually get the request flowing in. I'll write the logic, because Kotlin is my programming language. But then, what about the database? Database is something which it's a little bit complex, because you don't know, you need to create transactions, you need to know, open a connection, flush the data. There'll be a lot of things you need to know in database, and if you do something wrong, and you are screwed up. In Android app, if you're doing something wrong, probably one user will get screwed up now. But here, if the service is down, no one can do anything. So, but if you look at Android, as I say, like 7 years back, we have something like green ORM. Like things started from writing your raw query to ORM, where object relational mapping, wherein your database will be visualized as objects, POJOs, and you actually operate on your POJOs rather than operating on your database. And there are going to be some frameworks that helps us to perform these queries on our behalf. So this is when you have room persistence, which we kind of the latest Android Jetpack library which you use to actually insert data, query data, whatever, for building offline first applications. And that's the exact concept we have in backend as well. The library that differs is Hibernate. Hibernate is something that's been used by a lot of people, so we are not introducing something new. So Hibernate is an ORM that performs the same thing for us. So you define your entity. If you look at the class, you have both of them are POJOs, the to-do. You mark them as entities. You actually mark the same thing as entity as well here. And you have a primary key, and then you define your columns, and you are good. So Hibernate takes care of the repository layer, opening a transaction, flushing out, creating a session, querying, select, update, inside. At the end of the day, it's all CRUD operations. And then that's how we software engineers make things. We make all of the use cases fit into this CRUD. That's all we do. But yeah. So, and this is all sorted out for me. Like the moment I have Hibernate, I can actually perform the CRUD operations. The data is stored. I can fetch however I want it to be, threads, and stuff like that. So I have the application ready. I have the APIs working. But then comes this. So this is my favorite code, because whenever a newbie joins my team and they say, like, I don't want to have unit tests, I'd say the same thing. If you don't want to unit test your product, the customer is not going to unit test your product. And most importantly, again, I don't want the backend engineer to come back and say, like, your code does not even have unit test cases, so I want to rewrite again. That's one thing I don't really want to even listen. So, of course, I need to write unit tests for my code base. And as I said, I was kind of started looking at something which probably is different in backend. Maybe people are doing something new in backend, but that's not the case. If you look at the database, the unit tests here, the libraries which I use are JUnit, Mockito for mocking, and Jupyter Engine. And here, the most fascinating thing is that these are the same libraries which are used in Android to write the unit test cases. So actually, it's not even a new library. It's the same library that I use. So if you look at the code base, probably everything is same except the background. So just to make a differentiation, I made one as a dark background, the other one is a light background. But yeah, so you can look at the annotations are the same, and the way I even stub the repositories, and everything pretty much looks same. So that's what, like, so even the test cases are also pretty much figured out. So I ended up writing test cases, so my code is at least 80% covered. And I would say, like, these are the main basic building blocks when it comes to building a microservice. But then, is it all? Definitely not. It has even more. As I say, like for the static code analyzer, you need to have the code analyzer, static code. You use SonarQube and different things. But for me, as an Android engineer, I don't want to introduce new libraries into the code base. So detect is something we all use in, at least I use Kotlin. KtLint is one thing I use, and detect is another one which we use for lint checking, for static code analysis. So that's the same thing. I even used it here. Gradle, of course, for all of the for the build tools. We use Gradle in Android. The same thing as I mentioned, like I use Gradle here. And coroutines, that's one thing. We use coroutines in our use cases or in Android as well. So you have a built-in support for coroutines in Micronaut, in backend as well. You can actually use coroutines. And dependency injection. Trust me, dependency injection in Micronaut is way too simpler and easier than the Dagger world. I have been through the pain of using Dagger and how long it takes, but of course it's beautiful. But yeah, so it's much easier when it comes to dependency injection. And yeah, I mean, the database migration, we start thinking about that everything is a problem for us when it comes to backend because we don't know what it is. But actually, it is way too simpler than what we do in Android. In Android, the database migration, whenever you have a new version, the backward compatibility, the issues which it comes to are immense. But actually, in backend, there are also more. But I would say, like, you have enough tooling and support that you might not face as often as you face in Android. So, and the next thing that comes to the picture is like, yes, I have the APIs, the tools set up. Now I have things end to end. It's not only just developing an API. I have the code quality. I have the unit testing done. And the next thing is about the build. How do you build and deploy it? And we think in Android, of course, like you build an API. You build the APK. And at the end of the day, you have a build folder. You do a Gradle, assemble, build, assemble. And then at the end of the day, what does Gradle give back to you is an APK. But what is an APK? APK is nothing but a jar file. At the end of the day, if you just rename it to jar, you will start seeing the classes. So it's pretty much the same. So and in backend, it's the same thing. You do the same Gradle build, Gradle assemble. It makes a build, and then Java file, Java-jar, and then you deploy the jar file. It's actually the same thing which you do in backend as well. And the only difference is that you probably might be using a different tool set or the commands, but at the end you create a jar file and then you deploy it in a Linux machine. And so I kind of explained that, okay, everything looks easy peasy. I know, Mani, you keep saying like things like this are super easy, but yeah, all of us, we are developers, we want to see the code, So let me show the code as whatever I kind of explained. I'll just give a quick brief of how it looks like. I kind of refrained myself to not do live demos, but I think we as Android engineers, we are pretty much habituated on Friday releases and live demos. So yeah, so if you look at the code base here, this is the code base. You see the structure is pretty much the same, like how we have it in. Let me just zoom in case if you guys can't see this. Cool. So the project structure here, if you see, like you have the source. Source is kind of an app module for us. And then you have a build.gradle file, technically, where you add your plugins, you add your dependencies. Yeah, pretty much the same as how you do it, your test configurations. And then you have your source module, the main. So this is where your code goes into. You have more or less, I use a flat structure. So you can see that you have a controller, you have your repository and use case, the models where you define your models, the exception handling, and then the database, the entity data, so which actually goes under entity. So if you look at it, this is where the controller comes in. The request flows through the controller. All you do is annotate with the controller, and that's all. And the rest of the things more or less looks the same. You inject the use cases, and then use case.execute. Probably you have a repository. So a repository is something you could just annotate with a repository, and that's all. You don't really need to do anything. If you are doing CRUD operations, you just extend it with CRUD repository, and you define the POJO where you are actually performing the CRUD on the repository, and that's all. And rest of the queries would be automatically done because CRUD repository exposes you save, update, and some of the things. But yeah, there are some scenarios where you probably wanted to write your own query. I don't know, but there can be scenarios where you want to have your own query. You could definitely, you can change this to a repository and then write your own function with execute new or whatever. And then you can even do something like a raw query. It provides you a query, and then you can write your raw query here. So pretty much sorted out. And one more thing you probably need to know about is like the most important thing in a Micronaut or any of the backend project is the configuration file, which is, we call it as an application.yaml, which is where it's like a manifest where you kind of define your activities and stuff like that. So application.yaml is where you provide your properties of how it should look like. For example, here my data source is the local database. So I'm kind of providing the database, username and password, and how to access. And that's pretty much it. If you see, like, rest of them are the same, like the application name, HTTP client logs, how long should it wait for timeout, and pretty much the same properties. And yeah, and if you look at it, like, there is nothing new. You use singleton for kind of injecting for a single instance, and most of the things looks pretty much same. Yeah, so probably I can run it, but I think I already run. So I created a controller where you can see, like, it exposes two APIs, two functions. One is like a getting to do items, and the other one is posting an item. And you could pretty much, I think the application is running. When it comes to running an application, it is application class. And if I'm not wrong, we do have application class in Android as well. So application class is the one which actually gets started, and we kind of inject things which we want that to be kind of living for an application scope. And even here, you have an application class as well. So all you do is, like, you run the application class, and that's pretty much it. And your app is up and running. So you can even test it. Like, I think I have it running. You can even post something, awesome DroidCon, for example. I think I'm mixing a little bit of German here, just to sound a bit German. Yeah, and that's it. So the moment you post, you have the data. Here, it's kind of, you have the logs, actually, to insert. And then you can just do a get query. Yeah, you get a little bit of data at the end. So I think then you can actually play around. The moment you have the flow working end to end, you could even do anything. I mean, you can see, like, local, but local is nothing but the IP address. If you know this, the IP address of the system, you could just use, replace it with IP, and that's all. So most of the guys, when we think like localhost, you think like, okay, it's going to work only in my system, but that's not the case. As long as you're deployed in any of an AWS or any of the cloud instances, you know it's API, that's it's IP address, and that's it. You can just run. So it's pretty much the same than what we think. So this is one thing, like, at the end, I have the API up and running. We are pretty much good, and we have, in fact, released the microservice, which is perfectly fine. I think it's working fine so far. I haven't checked my Slack messages, but I hope, like, it's perfectly fine. So back to our, yeah. So at the end, what happened for us? Like, I thought, like, it is going to take 4 or 5 months for me to kind of deploy the service because I don't really know how things work. But then I actually realized that most of the things we do in backend are pretty much, in fact, easier than what we do in Android. So it just took 2 months or 2.5 months for me to kind of deploy, and then Most importantly, the backend engineer who joined after that, although he has complaints, but he doesn't have bigger complaints that he wants to rewrite the code base. So I'm pretty proud and happy of that. So yeah, so we have the end-to-end feature development done. So now I have a very good idea of how the feature works, not only at the UI layer. So whenever a bug comes, I don't really need to wait for the backend guy to come and help me. Okay, hey, what's going on in the backend? Now I know, like I can actually jump into the code base, do a quick fix, and bam, it's up and running. So if there is a crash because of some value coming as null, sometimes it happens, and you don't really need to worry. You can actually jump into the code base, do a quick if check, just run the application. So you actually have a full control of how things works end to end. And most importantly, the freedom which you get. I don't really need to listen to the red taping which keeps happening. The discussions I'm pretty sure we all might have gone through in our experiences where I'll ask like, hey, this API is huge. You shouldn't dump me the whole of data in one API. It's a mobile application. User does not have a broadband connection added or a LAN cable connected, or the battery is super small, so you don't really need to dump me a lot of data. And they'd say like, no, this is how things work in backend. And it happened for me over a span of 6 years. But I don't think like they can tell all of that anymore to me, because I like a better word than red taping, but yeah, so they can't actually say some shit to me that, hey, this is how things work in backend. No, it does not. I know how things work. I can actually look at the code base. And even when it comes to discussion with the product teams, whenever a new feature comes, I won't be talking only about, okay, in the UI layer, things would look like this. I need to wait for the API contract. I need to wait for these things. No, it definitely not. Like, I can actually analyze how a system would function at a high level, so I can even estimate when it comes to tasks and their implementation and its timelines. So I'm not confined only to one layer. Now I'm actually having an exposure about a feature from the UI layer until the database where it is getting inserted into. So of course, there's a lot of sense of growth and have a lot of opportunities in terms of getting to learn different areas. So that's the perfect thing. I would say, like, as an individual, I think like I'm growing not only at one area, I'm actually getting to know different things without even putting myself doing something new. So which is super cool. So the code is in GitHub. You guys can actually have a look at it.